Next video in the mole concept series, and this is dedicated to the percentage composition. We are also going to look at the percent composition of hydrates. Hydrates are crystalline substances which have water of crystallization. Okay, so they are also called as hydrated crystals. So first and foremost, how do we calculate the percent composition of different elements in a compound? So step one, my dear students, is always to write the correct formula of that compound. And for knowing the correct formula, you should know the language of chemistry, which is the chemical nomenclature. I will say you should be masterful in the chemical nomenclature. And if you are already doing well, no problem. But if you need any help, you should go and watch the foundational chemistry blueprint course that is there in this particular program, which will help you to build your muscle for formula writing. All right, so the formula for finding percentage of an element is very simple. You take the mass of the element in 1 mole of a compound and you take mass of 1 mole of the compound. So once again, mass of the element in 1 mole and the molar mass, that is mass of 1 mole of the compound. How do you get this? We are going to look at some examples to understand this formula. But before that, pause the video, write down the formula and then go ahead. Okay, perfect. All right, so now let's go ahead. I'm sure you've written this formula. Otherwise, if not, just pause the video and then only go ahead. Otherwise, it will be very difficult for you to catch up something simple as this. Okay, and remember, these instructions are applicable for all our videos. So percentage of hydrogen and oxygen in water. So the question will ask is, what is the percentage composition of water? That means you have to find the percentage of each element in that particular molecule. So we know that hydrogen, water is H2O. So hydrogen are 2 in this and oxygen is 1. Also, mass of one hydrogen is 1 unit, AMU. But when we say molar mass of hydrogen atoms, it is 1 gram. Molar mass of hydrogen is 1 gram. Molar mass of oxygen is 16 grams. Since we have 2 hydrogens in this molecule, we'll multiply 2 by 1. So 2 grams of hydrogen in this molecule. Okay. And 1 mole of this substance and 16 grams of oxygen in 1 mole of this substance. Total molar mass is going to be 18 grams. So how do you find the percentage of hydrogen? Simple, right? 2 grams and 18 grams by multiplied by 100. Yeah. Similarly, percentage of oxygen is going to be 16 grams of oxygen in 18 grams of water. So that is the percentage of oxygen. Yeah. Let's see one more example. Another example is carbon dioxide. What is the percentage composition of carbon dioxide? Means what's the percentage of each of the elements of this compound? Yeah, so carbon is 12 grams. I told you molar mass of carbon is 12 grams. Molar mass of oxygen is 16 grams. In carbon dioxide, we have 2 moles of oxygen atoms. So therefore, total molar mass is 12 plus 32, which is going to be 44 grams. Percentage of carbon is going to be 12 over 44 times 100. So again, that's going to be 27.27% of carbon. Now for finding the percentage of the other element, like we saw in water also in this case, if there are only 2 elements, you can subtract the percentage of one element from 100. That's also possible. So you can see 27.27 if subtracted from 100 will give you 72.73, or you can find the percentage of oxygen using mass of oxygen over the total mass of the compound. So that was about percentage of each of the element. What is it when you have to find the percentage of water in a hydrate molecule? Once again, is a hydrated crystal. So every crystal has its own water of crystallization. So when you talk about barium hydroxide, every 1 molecule of barium hydroxide, I'll say every 1 formula unit of barium hydroxide is associated with 8 water molecules. I've told you in the previous videos also, when it is about ionic compounds, we say the particle is a formula unit. So here barium hydroxide is an ionic compound. So 1 formula unit is attached with 8 water molecules. So how much, if you weigh a crystal or a particle of barium hydroxide, you'll be weighing along with the water of crystallization. So barium hydroxide, once again, you know how to find the molar masses. Take the atomic masses from the periodic table. So 1 time barium, 2 times oxygen, 2 times hydrogen is going to give me the molar mass of barium hydroxide. Water also, 2 hydrogen and 1 oxygen together is 18 grams. But we have 8 such water molecules. So multiply by 8. So the total answer, students, the most common mistake, that most of the students do is they consider this decimal or this point as multiplication as you do in math. Like, so BaOH twice the mass is 171.3 and the water mass is like 8 water molecules, the mass is going to be 144 grams. Now, many times students will multiply 171.3 and 144, which is wrong. See, barium hydroxide has 8 water molecules sticking to it, so the total mass is going to be the barium hydroxide plus the mass of 8 water. Right? So, whatever is the molar mass of the molecule and whatever is the mass of the water of crystallization, you need to add it. So, once you add this, the total is 315.3 grams, so 315.3 grams. Students understand that this is a very simple mathematical problem, but only because of the misunderstanding, or I can say that misconception of this decimal or whatever this point is water of crystallization. We are going to add the two values. And now, what is percentage of water? Simple. Total water in this particular unit is 144 grams. So 144 grams over the total molar mass of the hydrated particle, which is 315.3 times 100 will give you 45.66%. Okay. One more example to reinforce this concept. We know that iron 2 sulfate or ferrous sulfate, which is a green colored crystalline solid, has 7 molecules of water of crystallization. So once again, how do you find the molar mass of FeSO4? So you'll take the atomic masses from the periodic table as I told you. So iron is, the atomic mass is going to be 56, sulfur is 32, oxygen is 16. So when you add all of this, you will get the molar mass of iron sulfate. And then you have to find the molar mass of water by finding the atomic masses of hydrogen and oxygen. Okay. Percentage of water is very simple. Just divide the molar mass of water with the molar mass of total compound, and that is 45.32%. So students, this video was dedicated to the percentage composition. There can be many more complicated questions based on this topic and connecting it with mole concept, but we are doing just the the simplest ones here, and the deeper ones will be done when we meet online. Okay, so if you are already in my online program, great, I'm going to do that work with you. And you know that if you are in my online program, you know that we play a lot of quizzes. So those who are not in the live program, join me, because not only we learn these concepts deeper, but we also do a lot of practice using quizzes, questions, and a lot of school papers. So that's all for this video. I'm going to see you in the next video, which is on finding the empirical formula and molecular formula using mole concept. Thank you. Take care. And I hope you are commenting after every video. If not, please start commenting and also write along with me, practice, and any questions, feel free to ask me in the comment section. Bye. Take care.